And as he does that, one quick note, today's event, we do want to encourage you guys to ask questions, be in the chat. There is a chat functionality, which I see everybody here is making all of their IP and UDP jokes already. There is a separate Q&A section if you guys want to just take a moment to find that. While Kevin's going to take the first half of this, maybe a little bit more, I am going to be monitoring that Q&A section. And as questions come in, if it's something that we can address on the spot, I will pause Kevin and we'll kind of address those things right then and there to make this a little bit more relevant to those of you that have joined. So just find that and feel free to ask questions in there. We'll pick those up as they come in. So with that said, Kevin, floor is yours.
Okay, great. Thanks, Sajin. So just quick check, screen sharing is coming out okay in the presentation?
We're getting affirmations. Kevin.
Cool. We're good to go. Okay. All right. Take that as a yes. Okay, great. So thanks everybody for joining. Let me introduce myself for just a second. My name is Kevin Myers. I'm a senior network architect with IP Architects, and I lead the engineering team here where we do a bunch of different things, which we'll get into. One of the things we've worked on a lot in the last few years has been deploying IPv6. We've got a pretty big ISP focus. But we also do some enterprise and data center work. So we're going to go into a little bit about what IP Architects does and then get into the meat of the IPv6 presentation, which this one is very service provider focused. But if you are joining from an enterprise or a data center, there's definitely a lot of takeaways here that cross over, networks into enterprise and data center networks. Definitely those are done a little bit differently, but there's some common things here as well if you're coming from the enterprise or data center space. All right. So IP Architects, we were founded about 10 years ago, and basically is an independent consulting company. We're well known for working with MikroTik, but we work with Cisco and Juniper and pretty much every network vendor that you can imagine. We're pretty versatile and spread out. Since 2012, when we were founded, which actually this year is our 10-year anniversary of founding, we've got offices in the US, Europe, South America. We've got a lot of different languages spoken across the team. And I think we've done everything on every continent except for Antarctica. So I'm still holding out hope that somebody down there is going to want something for a network project. But that said, we're pretty global. So who we are, I think in the wireless ISP space and the fiber ISP space, we're pretty well known. We've built a lot of networks in that space. We spend a lot of time on routing and switching, being an independent consulting company that's not a VAR. It is a very specific focus of ours, mainly because we really take to heart the idea that we want to be an advocate for our customers. And if we want to say, hey, this is the design that you need, I don't want to be the person selling you the design. And that's kind of the angle that we take, and because there's a space for everybody. And we think there's a great space for independent consulting firms to be that advocate for their client networks, whether that's service provider, enterprise, or data center, so that we can figure out the right design. So we only sell our time. We don't sell hardware. And we've been, like I said, we've been through pretty much every platform you can imagine on the RF side, optical transport, routing and switching. There's a lot in there. All the big ones that we work on are obviously Cisco, Juniper, Arista, Nokia, Huawei, IP Infusion in the white box space, and then MikroTik and Ubiquiti, and then a whole slew of other RF vendors. And the last point I really love that he put it in there were geeks and nerds. We love to geek out about this stuff. Our team is great. We've got a fun team that's really experienced. They really love doing this stuff. We spend a lot of time tinkering and figuring out how things work. And so at our core, we're very much a group of geeks and nerds and tinkerers when we're not, building big networks. So some of the services that we offer, if you want to look at engaging with IP Architects at some point, we have some of our clients on here that have already engaged with us that I noticed have joined. We do network discoveries and audits. If you want your network looked at to find out, how it's working, how it can be improved, we do that. We do strategy consulting on network life cycles. One of our strengths is that we've seen a lot of networks. I think in the last 10 years, I think we've done over 1,000 ASNs that we've been involved in building and deploying, mostly service provider, but some government, some data center, some enterprise. And we've seen a lot. We've migrated a lot of networks. And one of the things that we do a lot in strategy consulting is helping network operators figure out, what does this choice look like in several years? If I make this choice to deploy this way, how does that play out? And having worked on that many networks, we often have a really good idea of how that plays out. So that's something we spend a lot of time on. System software integration, automation. We've got a good DevOps team. We've got a little really talented people in that space that understand networking and coding, of which Sajjan is one of them, joining me here as he works on the integration side with the systems for IPv6. We do migration planning and execution. We do maintenance windows. We plan the migration. We've done a lot of those. I think one of our jokes inside the ops team is that I think we have a pretty high op tempo. I think we're in the middle of migration of probably 5 to 10 to sometimes 15 ASNs a week across our team globally. So a lot of network migrations going on. And then obviously break fix troubleshooting and incident response. If something's broken, you want help, we do a lot of that as well. So that's the basic 60-second overview of who we are and what we do. So IPv6, let's talk a little bit about IPv6 and what it is and how it helps us. Before I get into that, I wanted to take a minute to kind of say that I did my best to build this to cover kind of all experience levels. I know there's going to be some people in here that are very experienced IPv6 operators. They're going to know a lot of the stuff that I'm going to talk about. Some people may have never seen it. So I have an introductory section that may be repeat for some of you. But if you're new to IPv6, there are some basics and foundations that I think this will help. Then we'll get a little bit into design and deployment, and then subscriber provisioning considerations, which Sajjan's going to get into, which gets more into systems integration and billing. So let's talk about IPv6 basics. Oh, and a note on the cold call, I saw some comments about the IPv6 address. One of the nerd things we do, IPv6 wordplay, is practically a hobby of ours of figuring out new fun words that we can build into IPv6 addresses. So we're going to go over a few things and talk about a little bit about the history and background of IPv6, why it's important, a brief overview of the protocol and the mechanics of the protocol, and then some differences between v6 and v4. And then most importantly, how do I get some IPv6? So IPv6 goes pretty far back, actually. The discussions, I read some conflicting notes on this. I put 1994 as when the discussions first started in the IETF. I saw some notes saying that it went back as far as 1992, but it's fair to say in the early 90s, they recognized that the space that we were currently using in IPv4 was not going to last forever, and started down the path of building a new protocol. That protocol eventually became IPv6 in the first RFC, which was 2460 in 1998. And ever since then, it's slowly started to get deployed. And if you've been around IPv6 for a while, you know that it's taken a while to get there. It's something that we really thought would get more traction than it did. And we'll talk a little bit about that. The original IPv4 spec was all the way back in 1983. So late 70s, early 80s is when they first started talking about how to build IPv4 and then actually put it onto ARPANET in 1983. And for context, I think I was about 5 years old at the time and working on a TI-99 4A for the very first time, which is my first introduction to computers and computer science. So once we deployed IPv4 and realized that we needed to move on, we got into IPv6, and I think it was Windows, one of the first operating systems, as much as people beat up on Windows, to actually put IPv6 into deployment. I think Windows 98 and 2000 had production examples of IPv6. And that's where we started. And now we're, years and years and years later, and we're really getting close to deploying it. And some of the things that have been challenges in that deployment process have been NAT and just, and lower adoption rate, because, people really don't like change. So the service provider space has been really good in the last 10 years. Certainly there are some that need to adopt it, but it's gotten a lot better in the last 10 years. The mobile operators were probably one of the first to get it out there. And then as the wireline networks started adopting it, it got better and better. And then larger enterprises picked it up. A lot of the main content providers on the internet, YouTube, Netflix, and those kind of shops started to get it out there. I think I remember the first World IPv6 Day I was on was in 2011 or 2012. And we had this big IPv6 party on the internet. And it's really neat to see 10 years later that we're finally getting there. A little slower than we thought, but we're getting there. Some of the things that people sometimes feel frustrated with are the hexadecimal addressing format. And I promise you, once you work with it, it gets a lot easier. It can seem like a lot harder to deal with. You're dealing with more places for numbers and letters. It's a little more complex to subnet, but once you work with it, it's really not that bad. But there is a perception that when you're used to integers and moving into integers and letters in a hex format can be a little bit harder. So there's been a little resistance to get down there and resistance to change. Let's talk about why it's important. And I'm going to talk about this specifically in the context of a service provider, but a lot of these cross over as well to other environments. Just having less state without NAT points. IPv6 end to end is a huge thing. And while I don't know that we'll ever be completely IPv6 end to end, which was the original concept of IPv6, that we would never have IPv6 NAT and we would always be end to end on publics. I don't think that's the operational world that we're headed into. Most of it is, but you will see some things get brought forward from the IPv4 world as enterprises adopt it, and we'll settle into a bit of a hybrid state in the world of IPv6. But for a provider, being able to put a public address out and have end-to-end addressing is great, especially for real-time traffic. If you think about where we've been in the last 2 years in the pandemic, getting real-time traffic onto addressing like IPv6, where we don't have NAT in the middle and voice and video, is great. And there's tons of native content out there now. Like I said, Netflix, YouTube, Facebook, Google, the gaming networks are all onto IPv6 mostly. There's a few things that they haven't gotten on there. But as an ISP, most of the things that your customers care about, like a good 50 to 60%, is out there on IPv6. So when you enable IPv6, you can offload a ton of traffic. And having publicly addressable routing just lowers your operational cost. If you're not dealing with NAT issues when your customers call in and said, "Hey, Xbox told me that I'm using this level of NAT and it's not great." Once you have those V6 addresses out to your subscribers, it makes things a lot easier. You don't get as many of those. In fact, all the ISPs that we put it into production for have reported that kind of problem with NAT, which is now we're starting to see pop up in the last year. We've had stricter NAT policies from Netflix, Disney Plus. A lot of the video content operators have really tightened their NAT policies. So if you have IPv6 deployed, that just makes your world that much better. And then one thing that's really unique to the service provider space is the streamlined header actually makes it a little bit easier to compress the header for RF networks. So when you get into commercial radios and point-to-point radios and licensed microwave links, where they're doing some really cool things and deduplicating headers to improve the throughput on some of these networks, where in some remote environments, we do a lot of work up in Alaska. There was one network we worked on in Alaska that I think the microwave backbone went from 2 gig to 4 gig because they were able to compress and dedupe headers. And IPv6 has a simpler header format, which we'll see as we kind of break it down, which for an RF operator, that makes things a lot easier moving forward. So there are some real tangible benefits that, other than just it's really, really big, that people don't always think about. Is it faster? This is probably one of the most hotly debated things that we finally started to see some empirical data around. Is a lot of people said IPv6 is faster. Some people say it's slower because it has less usable space for payload than IPv4. But in either case, when you look at this, Apple did a study in 2020. I think it was summer of 2020, where they said they saw about a 30% improvement on their app response time over their native IPv6 network. Now, it could be for a variety of reasons. It could be because of NAT congestion. It could be a whole bunch of different performance issues in IPv4 where you're maintaining state in some way, which happens a lot in v4. But they put the data together, and we'll try to find a link to put out here in the chat. But they definitely showed where things were a lot faster on their network. So I think there's a case to be made. You're not going to like double your speed or anything, but I think there's a case to be made that it makes it a little snappier because you are getting off of some congested CGNAT gateways on the global internet. And it's more expensive. IPv4 has gotten really expensive. Anybody that's on here that's tried to buy IPv4 in the last few years has realized that the cost is going up, and we're starting to reach that point that everybody kind of thought we'd get to closer to 10 years ago, where it gets expensive, it gets harder, it's a more scarce resource. And, that's IPv4 is kind of going through its last throes. People are still finding ways to get it out of, universities are selling some of it. So we keep having dumps into the IPv4 pool, but, we're generally getting into this point where IPv6 is definitely got a lot of traction. It's out there. I think there was a statistic I saw where we crossed over 51% of mobile operators in the US in December of 2021. So we finally crossed the 50% threshold. And that was a big deal. So getting into the header a little bit, let's talk about the header in IPv6. The first thing you'll notice, and I'll put this against the IPv4 header so you can see it, it's a lot more simplified. You don't have nearly as many header categories that you've got to deal with. And you've got some expanded QoS capabilities that actually has more granularity and control for QoS capabilities. One thing you don't see is a fragment header because routers can't fragment a packet in IPv6. The source node can, but a router in the middle of a path, unlike an IPv4, you can't fragment it. So your MTU's got to be right or it's not going to work. So this is something that's really helpful with IPv6 is the streamlined header format. Let's take a look at an address and what it looks like, and you'll see several examples of this. Aaron had a good graphic here, so I pulled it out. And anywhere the graphics are used, I've got a source down there of where we pulled it from. Often it's right, Aaron, Wikipedia, most of those sources. But this is what a /64 looks like as you break apart the address. And you've got basically 8 places between the colons that you're putting an IPv6 address into. So you have the routing prefix in this case, which identifies the routing portion of the address, the subnet ID, which this is a /64. So the subnet ID takes up 1 quartet. And then you have the interface ID, which is like the host portion of the address if you're coming from the world of IPv4 addressing. And that makes up probably the single most common subnet that we see in IPv6, which is the /64. Most everything is aligned around a /64 in the IPv6 world. It's what we want to give out to servers. It's what we use for point-to-point addressing. It's what we want to use for subscribers. Once we give them a prefix, they'll pull a 64 out of it and put it in their home. Most of the world of IPv6 revolves around the 64. And I've got an example here from a MikroTik router. It would be similar in a Cisco or Juniper or Nokia router that shows the 64 actually assigned to an address, to an interface on the router. So looking at the addressing format, you've got 128 bits to work with. And in the IPv4 world, we call the positions octets, as we have 4 places for IPv4. In IPv6, there's actually a lot of different names for this. I call it a quartet. There's another there's like 3 or 4 official names for what you call this, but I most commonly call it a quartet. And there's an official name that's really long and a little cumbersome, so I don't normally use it. But you have the most significant bit all the way on the left side, just like you do in IPv4. It's just a lot longer, and the least significant bit all the way on the right side. And then each of these quartets breaks down into binary, just like IPv4 does, showing the binary encoding of each of those positions. The only difference is the binary will look a little bit different because you have hex in there. So you've got, letters that you can put in there. So the way it appears in IPv6 is a little bit different at the binary level.
Hey, Kevin,
Yeah,
we have a quick question.
yeah, shoot, what you got?
Go back a couple. So
Yeah.
it's a valid question. So everything is aligned around /64s, but we do use smaller chunks when we're doing point-to-point links and peering, correct? We use we actually go down to like actual /120, 128 or something.
So that's a really good question. So let me talk a little bit about our journey on that, because we used to use longer addresses. So in the IPv6 has been as much of a journey in the IETF and for operators as it has been for people on the outside looking in. So originally, you'll find that providers that have been around for a long time will use point-to-point addressing like /127, /126, /120. All of those were very, very common. And the reason that we use those smaller addresses is because there was a fear that different kinds of attacks on the data plane and the control plane could potentially do like neighbor discovery exhaustion attacks, because the space is so big in IPv6 that you have an ability, if you're spoofing something, you can really knock a router out. 10 years forward, they've gotten really good at locking the control plane and the data plane down. So that's not really as much of an issue. So most of the operators are going to use 64s from points to points because it's easy to put in the IPAM. It's easy to address. It's really easy to work with. And anything beyond a 64 starts to chew up more TCAM in a lot of routing platforms. There's some work being done where it makes it a little bit easier to use longer prefixes if you want to. I think I saw the P4 community working on that, on how to do that. But a lot of the platforms that you're used to working on, you'll chew up more TCAM space if you're in an ASIC-based network device when you're using subnets that are longer than a /64. So in order to be mindful of that table space, the only one that we tend to use, unless it's a a special exception as a /128 for a loopback. And then we put the point-to-point addressing in as a /64 to save on that table space. So that's why the addressing is where it is. Now, that said, if you have a router that has a specific security vulnerability or security concern that you're okay with being in production, but you're worried about one of those attacks on a 64 using, all of those billions and, zillions of IPs that are out there potentially, then you could move to a /126 or a 120 or a 127 if you had a specific concern about two routers. And I've seen that done. But in general, most providers are moving towards /64s. And as you look at peering handoffs from providers, the providers that are going through network refreshes are starting to hand 64s out for transit providers. Whereas providers that have been around a while and haven't been through a network refresh, you'll still see /127s, /126s, /120s. So there isn't like a wrong answer here, but if you're going to have a lot of routes in there, you do have to be mindful of table space. So that's how that breaks down. So going back to the protocol overview, there's about 4 different types of IPv6 space that you can work with. There's link local, which we actually had in IPv4. We had a 169.254 address that's now gotten common for like AWS peerings and things like that. That is foundational for IPv6. IPv6 uses link local for communication. It uses it for next hops. It is essentially the underpinnings of IPv6, and it's something that exists only on an L2 LAN segment between two devices. Then you have global unicast, which we abbreviate as GUA. This is what people would commonly call public IPs, public addressing, because this is globally routable. That's why we call it global unicast. You have the multicast ranges that are needed for whether it's multicast because you want to route with PIM. If you want to do the mechanics of routing protocols, things like VRRP, they all have their multicast addresses that come out of the multicast range. And then there's this fourth space called unique local, which we mostly abbreviate as ULA. And it is kind of a private IPv6 range. You'll find that in the IPv6 community, the use of private addressing is discouraged. But if you have a use case for it, that is the IP range that you use is the ULA. And something interesting about it is that it's depreferenced against IPv4. So if you're using DNS, most host operating systems like Windows, Mac, Android, Apple, iPhones, iPads will always prefer IPv4 over ULA. So if you're in a situation where you may have a global unicast and a public IPv4 or private IPv4, and you have a need for a third type of IPv6 addressing, there may be some systems reason that you need it. It won't use that for internet access because it'll be depreferenced against IPv4 or IPv6, depending on the DNS entry. So those are the basic address types that we have in IPv6. Now let's take a look at the IPv4 and IPv6 comparison of the header types. You'll notice that the IPv4 header is a lot more complicated. There's a lot more things in there. Well, we've already talked a little bit about fragmentation, but the other thing that you'll see in there that isn't in the IPv4 header is the checksum. So back in the old days of networking, when we were dealing with frame relay and X25 and ATM and things like that, IPv4 was constructed in a world where networks were generally considered unreliable. So there were a lot of extra checks to make sure that data was arriving in the right way. The checksum is one of them that lives at layer 3. Anymore, we rely on layer 4 to do that. That's happening in TCP. If it's UDP, then it doesn't really care, because if it doesn't get there the way it wants, then it's just gonna keep sending. But in TCP, you have a checksum as well. And so IPv6 dropped the checksum at layer 3 so that it could move that up the stack a little bit. And I don't know that I've seen any empirical data around this, but that's one of the theories as to why IPv6 is perceived to be slightly faster, is that you're not doing a double checksum calculation on every packet. You're not doing it at layer 3 and layer 4. You're only doing it on layer 4. Obviously, that's just a theory. I haven't seen any empirical data around that, although it'd be interesting if somebody had some. Few other notes as you look at V4 and V6 side by side. There is no ARP. In V4, everything is revolves around ARP to get an IP bound to a MAC and to make that relationship in layer 3 and layer 2. That's replaced by ICMP v6 and neighbor discovery. So basically, those two things join IPv6 addresses with MAC addresses and get them to communicate across layer 2 and layer 3. And broadcast is then replaced by multicast. So the multicast ranges that you saw, there's a bunch of different multicast addresses that are used on a LAN segment for various things. One of the interesting things operating is ICMP-v6 becomes very, very important. So people that are used to blocking ICMP, if you want to live in an IPv6 world, you have to be very mindful that if you are going to block ICMP, which in most cases you don't need to, but if you have a security posture that requires it for compliance or something like that, then you need to be mindful of making sure that you permit the required ICMP-v6 types that you need for the protocol to operate, and then blocking everything else. Neighbor discovery allows hosts and routers to see each other, and then they can also exchange something called router advertisements, which communicate information about a LAN segment. That's a whole other topic. I didn't want to get too far into those because it's a whole topic in and of itself. If you want to learn about those basic mechanics of IPv6, definitely go check out neighbor discovery and router advertisements. And there are some great IPv6 courses out there. If you look at Aaron and Ripe, there's a whole slew of IPv6 foundational links that will help you learn the mechanics of the protocol. And to get just a little bit more into fragmentation, this is something that is still a little bit of a battle on the internet. Cloudflare has a good article on this, in that IPv6 actually has a minimum MTU, whereas in IPv4 you can get all the way down to, I think, 64 bytes before you're going to get a packet discarded. But in v6, you've got a minimum MTU of 1280, and your ideal MTU is 1500. But if you're on an RF network, for those of you that are WISP operators, if you're operating LTE, CBRS, even some unlicensed, RF networks, because of the overhead in the RF layer, their MTU for a segment towards a subscriber may actually come down to be a little bit lower, which makes path MTU very, very important. It doesn't mean that it doesn't still get blocked, but path MTU becomes very, very important. And one of the fixes in the past for a problem with IPv6 and fragmentation was to lower the MTU to be as low as it could be, which is kind of an old hack. And thankfully, we don't have to do that anymore. Most of the MTU segments on the internet are correct; they work, and we don't really have to deal with that anymore. But for context, 1280 is the minimum.
Hey, Kevin.
Yeah, what's up?
Quick question. The concept of jumbo packets are still the same in v6, right, on the high end?
Correct. You can definitely go higher if you want to in your backbone. So you can always go up and have higher level packets. You just have a different floor with IPv6 as compared to IPv4.
Perfect.
Yep. So we've talked about link local, that it can be used for a bunch of different things. It's used for routing adjacencies. We use it for next hops. As a service provider, you probably want to have GUA on there as well, so that your trace routes show up with routable addresses to make trace routing easier, but you technically don't need it. You can do routing adjacencies over link local addresses, and those work just fine. As well as, routes, whether they're dynamic routing protocols or static, they work over link local with no issue. And one of the other things that's fundamentally different is multiple addresses per interface. Any network engineer that's been around for a long time is probably going to tell you, coming from an IPv4 world, that putting a bunch of addresses in a single LAN segment was a bad thing to do. It's always been, no, you don't want to put 3 or 4 or 5 addresses. We use VLANs for that. But in the IPv6 world, having multiple addresses is a very regular and normal thing to do. So there's a bit of a thought shift there, in that there are times when you want to segment into a VLAN and you still have that. But inside of that VLAN and that L3 gateway, you may have a GUA address. You might have a ULA address. You might have multiple GUA addresses, depending on, where you are and what you're doing. So just checking into the idea that it's normal to have multiple addresses per interface is very much a thing in the IPv6 world. So I'm going to preview a little bit about what Sachin's going to talk about by talking about how we hand out addresses in the v4 world as compared to the v6 world. In the v4 world, there's probably more ways than this, but I covered a few common ones in the provider world, which are statically assigning an address using DHCP v4 server, which is going to maintain a lease file, and it's going to hand out a single address to a customer. You could hand out a subnet, that's sometimes done, but most commonly it's a single address to a customer. And then PPPoE, and we would also use PPPoE to get an IPv4 address to a subscriber. In IPv6, it's a little bit different. Very rarely are you handing out an address. If you're going to be handing out an address in a IPv6 world, it's probably going to be on a LAN segment for management, for a server, something like that. You're almost never going to be handing out an address to a customer. There's probably some notable exceptions to that, but for the most part, you're going to be handing a prefix to a customer instead of an address. And we have a protocol called DHCP v6 prefix delegation. And that basically is interoperable with just about any consumer router that you would get out there, to where you pull a prefix as a subscriber, you pull a prefix from the provider, and then a dynamic static route on the delegating router gets built to be able to reach that subscriber. And that's how you're able to get to that subscriber, is through that mechanism. And that can be distributed. You can maintain the DHCP v6 PD config on the router itself, or you can do it centralized. If you do it centralized, one thing you'll find out is that not every router supports the centralized prefix delegation. So that's hit or miss depending on the router and the code. So you have to be mindful of that. And then you have Slack. And Slack is what almost everybody uses for assignment. It's something that we is almost universal, because you're able to take a /64 out of a pool, most commonly with what's called EUI64, which is you take the MAC address, add some bits to it, and create a host address out of it. And you're able to put that on a LAN segment where any host that joins just gets a unique address with that, and it's stateless. It doesn't maintain a lease file the way DHCP-v4 does. It just uses the MAC address. You don't have to use the MAC address. There's other ways to do that, but that's the most common, is to use EUI64. And any host on that LAN segment can just pull an address and work. And so servers work that way. Subscribers can work that way. And Slack is also what you'll find on hotspots on phones. Your home internet connection, if your provider manages the IPv6 for you, you're likely going to find Slack on there. And then finally, we have PPPoE, which oddly enough, if you ever worked in the PPPoE world, people never associated DHCP with PPPoE, because DHCP was traditionally Ethernet. But in the v6 world, you can have a PPPoE connection and still use DHCP v6 prefix delegation over PPPoE. If you're in North America and Europe, you're probably going to find the mention of PPPoE to be very archaic. If you're in Asia, especially if you get it as you get into Australia, New Zealand, Indonesia, there are vast ISP sections there that still use PPPoE. So depending on where you are in the world, the mechanics of the way you do this could be very different. And that's why I bring up PPPoE and mention it. So how do I get IPv6? And I look at how I get IPv6. If we look at the way that the addresses are handed out, there's IANA, which is the Internet Assigned Numbers Authority. They basically have they record all the addresses. And then the regional internet registries, which if you're a provider, you're probably familiar with working with them for IPv4. They hold /12s that they then dish out addresses out of. So we've got here in the US, in North America, we have ARIN. If you're in Europe, you use RIPE. If you're in Latin America, you use LACNIC and AFRINIC and APNIC and so on. And those are the main regional internet registries. The local internet registry is what you get, basically what you maintain in your addressing plan. And most ISPs are going to get a /32. /32 is for, especially if you're a tier 2, tier 3, WISP, FISP, that's most commonly what you're going to get. Most enterprises tend to get a /32 as well. If you have a bigger organization or you're going to be doing like a lot of development or lab work, I've seen allocations go all the way up to like a /24. For some states, we'll get that. Or, if you're a cloud operator, you might get something even bigger. And then out of that, you'll see common assignments like a /48, which is very common to an end host, /56, also very common prefix to assign to an end host. And then those are that's the PA space that you would give to customers that aren't going to go to the RAR and get their own. And then you have /48s, which are provider independent. That's the smallest boundary in the global table for BGP that you can advertise at the moment as a /48. So before we go into kind of network design, I want to close this section out by talking about how do I get IPv6? If you've never interacted with an RAR, let's say you're a new ISP and you're not familiar with working with ARIN or RIPE or whoever it is. I've put ARIN on here because they have a how do I get IPv6 page. The others do as well. ARIN has gotten really good about this. It used to have to kind of hunt around for how do I make this request? What do I do? 10 years ago, it was not this clear. ARIN's done a really, really good job of organizing it and making it super easy to click on this aptly named page, which says your first IPv6 request. And they have a video and tutorials that basically walk you exactly through how do you sign up for an ARIN account? How do you request your IPv6 prefix allocation? How do you request an ASN, which isn't technically required to get IPv6 space because you could have another ASN advertise it for you. but most people are going to get an ASN. So definitely check out this link from Aaron and go look at that, because if you're unfamiliar with how to do this, they do a phenomenal job of walking you through it. So that ends the intro to IPv6 section. Sajid, I don't know if there's any questions that you want to throw out there. I'm going to pause for just a brief moment before we go into network design.
Yeah, we've been pretty clear on questions so far. I do want to just make an announcement on time before we move on. Section 3 is my section on the subscriber management provisioning. If we do end up over, we'll keep going on this webinar. It'll be recorded and it'll be sent out most likely on Friday to anybody that registered. But if anybody wants to have a private conversation afterwards, if they have to jump off this particular event, that's completely fine. We can schedule that as necessary.
Okay, great. So let's talk about getting IPv6 into your network. We've gone over some very brief basics. And again, that was like a really, really quick overview. You really want to go into Aaron and a lot of the resources out there on the internet and get yourself a lab. For those of you that are network operators, if you use GNS3 or EVE-NG, which is EVE-NG is what we tend to use, there's a lot of free images out there for routers that you can get IPv6 working in a lab. And, if you play with it on your phone in your house, those are all really valid ways to get working with IPv6. So, if you've never touched it, get it in a lab, play with it on your home connection and get some flight time on it, because once you start configuring it, it'll become a lot easier for you. So the first thing I want to talk about is how to break up the address space. And there's a whole lot of ways to do this. One of the things that I try to do, especially when we're deploying for the first time for a provider, is try to get an addressing plan that is simple and deployable and has a little bit of a home for everything. Everybody kind of wants to shift it in different ways, just like IPv4 subnetting, which is probably worth mentioning that subnetting is the word that we use. Technically, IPv6 doesn't have subnets, but I know I'm bad about saying subnetting, and I know most of the IPv6 people that work a lot in it use the word subnetting, even though technically we're talking about address planning, prefix allocations, and assignments, because there is no actual subnet as part of the protocol. So just to make a distinction there. So we're going to talk about the address space. We're going to talk about where do I start, as well as looking at an overview of dual stack design and single stack design in your ISP. So the first thing that I would recommend that you go do if you want to do some IPv6 planning in addition to a subnet calculator is download Netbox. Netbox is an open source. Calling it an IP address manager is not quite fair because it does way more than that. It does inventory management, peering management. There's a whole bunch of things that it does. But one of the functions that it does really, really well is IP address management, and especially getting IPv6 in there in a way that's easy to see. So this is an example of an addressing plan that we have. Again, this isn't the only way to do this. It's one way to do this, where we took a /32 and broke it up into 4 chunks as 34s so that we could have basically pretty even space to start building out infrastructure out of, which you see here in the screenshot, where these are where we break out things like management and loopback addresses and point-to-point addressing and any other kind of special purpose addressing that we would need that doesn't fall into the data plane. We'll break out into that first /34 where we're going to be doing all the infrastructure work. Oftentimes I don't make it site specific. Sometimes it is site specific, but I'll often have loopback ranges and point-to-point ranges that aren't site specific, so that if you're a WISP operator or even if you're a fiber operator, one of the things that can really get mired down in as you're doing an addressing plan is like, which site does this point-to-point link belong to? Does it belong to tower 1 or does it belong to tower 3 that I'm linking to? So in order to kind of remove that confusion, we tend to not assign things that are universal across the network to a site, but just leave them as a high-level prefix pool to assign from. And then things that squarely fit into a site, like a router management address or a gateway for a subscriber subnet, we'll put those into a site. So this is something that you can take and a tool that you can use to break out an addressing plan. And Netbox has got a good active community. They've got a lot of different examples of using IPv6. I think they've got a forum on Reddit. And if you want to get some help on using Netbox or understanding how to use it or examples of addressing plans, definitely go check out the resources that are there for Netbox. And we'll talk a little bit about how we use it and how we break it up. But at a high level, what we try to do is essentially /34s. We break into /34s, sometimes 36s, depending on what the ISP wants to do. And then out of that, we usually pull like a /40. for a tower or pop site that will then pull out of that slash 40 48s that go into the data plane. And that's the last point that you're going to be at. A slash 48 is where we pull the slash 56s out of to give to customers. And then we'll often keep a pool of slash 48s to go to enterprises. And that highlights a little bit of a difference in the way small operators and large operators work. My take on this is, and there's a lot of different opinions on this, if you're a smaller operator, there's no real reason to give everybody a 48 if you have a lot of sites, because especially for a WISP, if you have micropops, you may have a lot of sites, but not a lot of customer density. So just from a site planning perspective, you could kind of go through a slash 32 if you give everybody a 48, if you have a lot of sites, and then you're going back for another registration to register another prefix, and it's another fee, and it's not the end of the world. It's not an enormous amount of money. But for some of the ISPs that get started on very, very small budgets, if you don't need to blow through the address plan, doing a slash 56 still falls under best common practices, and it works pretty well. If you're a larger provider and you want to standardize on slash 48, that's great too. I think slash 29, if memory serves, Aaron and most of the other regional internet registries will they'll allocate like a slash 29 for you. So even when you get your first slash 32, there is space behind that reserve that's sequential to your original allocation that they'll give to you. And I think it's a 29 is what they do. So anyway, getting back into how we break this up, this is the way we break it up at a high level to get into the next slide, which is here's the core. Now, there's probably an important point here about nibble boundaries. And if you don't know what nibble boundaries are, you should go check those out, because it's how we align addressing to make it easier to work with. It can impact things like reverse DNS. So when you're putting a routable prefix into the table, you definitely want to be aligned into a nibble boundary. When you're building out buckets of space that are never going to get announced as an aggregate, then you can cheat a little bit, and you don't necessarily have to have those aligned to nibble boundaries, because they're just kind of containers of nibble aligned prefixes that you do want to assign out. So as you're doing your planning, definitely go read up on, I think Afrinic over in Africa has a really good overview on address planning and nibble boundaries. So definitely go check that resource out. But here we've got some pools where we're pulling out point-to-point addressing for our core routers. I think we've got 2 border routers, 2 aggregation routers, and 2 core routers that we're doing point-to-point addressing for here, and we're using slash 64s. Going down a little further into the address planning, here's where we get down like into the last mile. And I threw the IPv4 in here so you could kind of see that as well. But this is in a dual stack network. This is kind of everything that you would need to do management, CPE management, and customer data plane for IPv4 and IPv6. So in this case, we're using the CG NAT range 164.0.0/10, along with our GUA for IPv6. So if you look at the customer data planes, we'll have a 100 dot address that's coming out for a customer in the data plane. In this case, it's 100.80.00/24 for this tower. We're going to be assigning an address out of that to go down to the customer, and the tower route will be the gateway for that. And then if I come down to the bottom to my IPv6 equivalent, I've got 3 slash 40s that I've reserved here that are going to be for 3 different data planes. And the reason we call them data planes is ISPs anymore in the tier 2 and tier 3 space often fit into a very hybrid category. Most ISPs that we work with these days are doing some fiber, they're doing some CBRS and LTE. They're probably going to be doing some kind of unlicensed, fixed wireless broadband in the 5 gig space. There's still some people doing the 2.4 space, and some people even still doing 900 megahertz. So generally, when we plan for this, we break down the data planes so that you kind of have a home at every pop tower, whatever you call your sites, so that you can pull slash 48s out, as well as slash 56s for those different types. And so this gives you big pools to pull out of. And that's one of the nicest things about IPv6 is you don't really have to worry about running out as much, and you don't have to kind of obsess the way you did in the IPv4 world of, did I get my subnets right? Am I going to have to go back and add a weird numbering because I didn't have enough? You can really give your sites plenty of addressing and still have a ton in reserve to scale your sites out. And so that's one of the nice things about IPv6 is it's not about addresses anymore. It's really about sites and prefixes and how you want to break those out and make sure that your routable prefixes are aligned to nibble boundaries. So Sajin, I'll pause there. I don't know if there's any questions on addressing before I get into getting into network design.
Nah, nibble boundary became the word of the day though, so we're good
Yeah.
otherwise.
Yeah, for sure. So before you put this into your network, make sure that you secure your control plane. And that's really, really important, because if you're an ISP that's used to working with private space and you don't really have public space on a lot of your infrastructure, then, not that you shouldn't be securing your control plane, but, it definitely happens where routers that aren't internet reachable don't get as much security. Anywhere you're putting GUA on, you need to make sure that you're securing that control plane so that people aren't attacking it. Now, that said, one of the nice things about IPv6 is it's a lot harder to attack. Certainly not impossible. Doesn't mean that you should take a lax approach to security, but trying to figure out, the 128-bit, combination of address that somebody's used requires a lot more work on behalf of whoever is doing the attacking and the reconnaissance, which just means from a probability standpoint, and when I go look at our logs on our data center for our IPv6 stuff, it's a lot less. Like, I just don't see the garbage coming in on IPv6 that I see coming in on IPv4, which, used to be people would say, well, nobody's using IPv6. But I think the answer today is that it's just, hackers go after the low hanging fruit, and IPv6 is often not the low hanging fruit. So I'm sure 10 years from now that may totally change. But operationally, and we've seen this in a lot of customer networks, IPv6 just doesn't get hit with garbage as often. That said, you still need good, good control plane security. And then make sure you add protocols that you're using in your control plane security: BGP, OSPF, ISIS, LDP, SRM, PLS, whatever you need for your protocols to work, in addition to common mechanics for IPv6 like ICMPv6. Make sure that you're adding those to your control plane filters. Okay, so let's take a look at, how do I get this started? This is the question that we probably get the most often, is how do I actually get this into my network? Because it's really hard, if you don't do a lot of network migrations, to figure out, where do I start? So figuring out where you start is a bit of a challenge. And what I like to do is start at the border. And because this is the easiest place to get IPv6 in. Even if you have an all IPv4 network and you've never touched IPv6, configuring the point-to-points to your transit providers or to an IX on your borders, and then announcing your space with a link between your routers and a subnet that you have between your routers, as well as maybe a couple loopbacks, is really, really easy. It's really not terribly hard to do it. And because you're not messing with the V4 forwarding plane or routes in general, you probably still want to do this in a maintenance window if you're, concerned about messing something up. But in general, they're different protocols. They have different routing protocols that follow entirely different next hops, and they have different fibs. So it's something that you can do, and it's pretty low risk and it's low effort to get this in there. And this is where we always start with client ISPs: is let's get it in at the border, announce your aggregate, which is probably going to be a 32, but it may be more, it may be less, and then get some loopbacks, and let's make sure that route's on the internet. And if it doesn't, then let's troubleshoot. And this is probably a good time to point out that if you're not using the internet routing registries, or doing signing of your prefixes, your ROA and ARIN, if you want to read more about those topics for routing security, go into ARIN. They've got sections on both of those. But when you own a prefix, having an ROA for the prefix, a valid ROA, as well as the IRR entry, is very, very important, because their transit providers are tightening down on that. So the next logical step is, obviously, let's get it in the core. We got it in the border. Now let's get it in the core. So now we're bringing our IGPs into play, most likely. There's a few cases in wireless ISPs that are all eBGP that just have private ASNs, but most ISPs are going to have some kind of an IGP, whether it's OSPF or ISIS. And we're going to put those point-to-point addresses on there, and start building routing adjacencies with our IGP, and peering for IBGP if that's the way that you're built. And this is something that is, again, do it in a maintenance window. Check your code on your routers or your switches in case you need to do any kind of updates for IPv6 vulnerabilities or bugs. But again, bringing it one hop in is not terribly hard to do when you overlay it on the same point-to-point links that you're doing your V4 addressing on. And then you get things up to the core, and then you can originate a default route from your borders into the core and get it to that point. And then finally, aggregation. So your aggregation routers, PEs, BNGs, your network may not look exactly like this, but this is a very common design that we use, which is why I laid it out this way. And that's the last part in a data center, or a POP that we'll put it in, is let's get it out to the aggregation routers. and make sure that we can route all the way through so that we can route prefixes in for the last mile. One thing you'll note that's missing here is, oftentimes BNGs, PEs are NAT points as you're aggregating customer traffic. We're not doing any NAT in IPv6, so you don't really need that function. You can just bring the prefixes back if you're using something like MPLS, VPLS, or you can route them back, you can overlay them back, but whatever you do, bring those to the aggregation point and then route them forward through the core. And then if you're doing any kind of shaping, QoE, that's a good place to do that as well. And you can start testing how that works at that point. In most cases, because these are overlay, like you're overlaying the IPv6 protocol, or overlaying is really the wrong word. When you're dual stacking it, you're putting independent protocols right next to each other. You generally are not disrupting the network. So as we baby step into the interior of the network, it gets easier and easier as you do this. So we talked about the terms dual stack, and we'll look at a single stack network here in a minute. The dual stack network is the easiest way to get this thing into production. Putting IPv6 right alongside your IPv4 is the easiest way to get into prod for most ISPs. You can configure the addresses right alongside the IPv4. If you look in the drawing here, you'll see that we're v4 end to end and we're v6 end to end. So we have our handoffs from our providers. We're v4 and v6 all the way through the core and aggregation, and then this point-to-point link to a tower, which could be fiber to the home, could be an OLT as well. We've got a point-to-point address to the router that serves that site, and then in this case, we're going to have a /40 at the tower that we're going to announce, and then a /24 of IPv4 space. And sometimes it's hard to mentally check into the difference between those spaces, because if you've only got a couple hundred subscribers on a tower, a /40 is a massive amount of space, and you can align that down if you want to. If you want to back that off to a 44, you can. But then that's where the addressing plan shifting comes into play. But really, again, it's all about, do you want to hand out 56s or do you want to hand out 48s to your subscribers? And then as we look at what's being handed out to a subscriber, another notable difference here, I'm handing out a single IP to this subscriber. I accidentally went to single stack. Let me go back to dual stack. I'm handing out a single IP to a subscriber here, but I'm handing out an entire prefix to a subscriber instead of an address. So in that model, one of the things that I always advocate for is, if you don't manage your own CPEs, then the IPv6 adoption rate is going to be a lot lower, because whether or not people configure IPv6 is up to them. It's, if their router they bought at Best Buy or Walmart or whatever was defaulted for it, it might be set for prefix delegation as a client. It may not. So when you're managing the CPE, which is what I most often recommend in design, because you can use it as a test point and you can still hand off to their own router if you have a customer that wants it. Then you can actually put that out inside the home network where you have v4 and v6, and you can increase the IPv6 adoption rate by managing that for the subscriber. So that's definitely my preference as a designer. But that's what a dual stack network looks like at a really high level and a really, really simplistic level. And one of the things that you can do if you want to, you certainly don't have to, but one of the things that's nice if you're a small operator and you're not really worried about, the subnetting, if you look at the letters that I used, you can use letters to make your world easier. I have B1 to B2 and the point to point for border 1 to border 2, border 1 to core 1, border 2 to core 2, core 1 to aggregation 1. You have so much addressing available that if using letters is helpful to you in your addressing plan, and it doesn't trash your addressing plan and your nibble boundaries, use the letters, use words. We use them all the time for special services. One of the things that Sajid and I joke about is we will often use D53 as the ending assignment for a DNS server for IPv6, because it's DNS and it's on port 53. It's very easy to remember. So definitely, as long as it fits into your addressing plan, don't be afraid to use letters. I think Facebook has Facebook spelled out in their CDN addresses that they broadcast out, or that they advertise out. So using letters it's fun, and it also can be helpful in your network. Let's look at a single stack network before I close up my section and get ready to hand off to Sajid. Single stack network is kind of where we're headed. And this really is going to depend on whether or not you're an MPLS operator. If you're not an MPLS operator, single stack is pretty straightforward in that you can use BGP to carry IPv4 traffic. I forget the RFC, but there's an RFC that allows you to use IPv6 next hops for IPv4 traffic. That pairs well with dual stack light. So it makes it really, really easy to take a v4 address all the way at the subscriber, transport it over a v6 only core, and then connect it to an edge that is IPv4 connected. And then you're probably you might have something like, NAT64 or DNS64 4 there to do the translation if you're not handing out a public address to your subscriber. And that most CGNAT gateways will handle that. So in a single stack network, the goal is to reduce the complexity and the addressing of all the transport by going single stack, and IPv4 becomes a service on top of that. Now, if you're an MPLS operator, there's a bunch of different ways that you can do this. Ultimately, you want to be working towards, single stack, but that's maybe a ways off for some operators. So if you have an IPv4 control plane in MPLS, whether it's LDP or SR-MPLS, there are a lot of operators that are probably going to live on that for a while. SRv6 promises there's a lot of potential to move towards single stack with label switching and services, but there are still some things about SRv6 that are getting settled in interoperability. It's still pretty new. So I think the gold standard, if you're an MPLS these days, is SR-MPLS and ISIS. That's what most operators that are running MPLS are using. Some people are still using LDP. If your gear only supports LDP, which is very common when we use like MikroTik and Metro Ethernet providers, often only support LDP, even though I think Calix is adding segment routing. I've seen Telco Systems add segment routing, and I think Adtran, I heard, is adding segment routing as well. So segment routing, SR-MPLS, that is, not SRv6, is definitely getting a lot higher adoption rate, and it's probably going to be the predominant type of MPLS over the next few years. So, but that's what it looks like in a single stack. However you get it over the top as a service, you're putting IPv4 on the top as a service and transporting it between the border and the last mile. So that wraps up my two sections of what I'm going to do before I hand over to Sajin. Are there any questions, Sajin, that we need to go through before we get into your section?
I don't think so. There was a question about IPv4 being the underlay, and I think you answered that when we're using some sort of MPLS, VPLS on top anyway.
Yeah, that's right. Like in most networks, just because size and complexity and ability to migrate are probably going to have IPv4 underlays for a while. There's only one SR-MPLS stack that I know of that can use IPv6 as the underlay. I believe Nokia can use IPv6 with SRv6 as an underlay, but most operators that are running, an MPLS data plane are probably going to be using IPv4 until they shift into v6. So, and then everything goes on top as a service.
And it might be important to note for everybody that's joined us that there are a lot of other avenues and aspects and fronts on this topic, because we haven't even got into like 464, XLAT, or how to deliver IPv4 as a service, as they say. So there's a lot of different deployment styles that there's no way to get into it all inside of this hour, but we can certainly explore in a different topic.
Yeah, I let 464 XLAT. It's a great one. It's kind of its own thing. That's why I left it out of there and looked at more like just having a router that, had a traditional v4 gateway that was going to use v6 as a next hop, or could use, MPLS to get back. That's a more traditional way to do it. Nothing wrong with 464 XLAT, but there are some more mechanics in doing that that are, like you said, there's a lot of complexity around that. And that's its own topic. So that said, I think I'll turn this over to you, Sajin.
Cool. Thank you for that. And I know we've gone over our time. It's awesome that all of you are still with us, but if anybody does have to go, I'll say it again. We'll send the recording out, and then just please reach out. Happy to show off some of my stuff privately as well. I may skip the live demo. All right. All right, do I have the screen now?
Yeah, you've got the screen. You're good to go.
All right. So obviously Kevin talked about all the nuts and bolts of IPv6, where it comes from, how to get it, how to deploy it, how to think about it at a overall network level, right? If you're talking about network architecture, how to use it and make it available. But as service providers, one of the biggest things that we have to deal with is, well, I shouldn't say we, but one of the things that service providers deal with is how do you deal with the actual subscriber, right? There are some really unique challenges. So I'm going to go through that process, and what our goals are and kind of how we achieve it and different options, and also kind of highlight some of the challenges and considerations as well. Um, the first thing that I'll do is just very quick note is just to add on to everything Kevin said is embrace IPv6. Um, as much as, in our chat, I'll play along and joke around as well. I do agree that there's some pieces of IPv6 that feel broken or not practical in normal operations. But if you just start embracing it, you'll find that it's really easy to just tag it on. As long as you have the right foundations. And I'll give you an example. On your web servers, email servers, DNS servers, oftentimes you're already using things that have supported IPv6 for probably a decade at this point. And it's a very simple config change to just make yourself v6 native. So you'll see a picture on the right. This is literally a power DNS recursor config. And for the most part, once you get the IPv6 address on the server, which let's just pretend it's Ubuntu, which is going to support Slack by default. So if your network is already set up for IPv6, this server would have already had an IPv6 address. And you're literally adding 4 characters to get it to listen on v6 IP addresses, and it's that simple. So kind of keep that in mind. Don't be scared of it. Once you start deploying this, it'll all roll into v6 pretty easily. Subscriber management, though, that's I think what a lot of people are here for. So let's talk about our goals. When we say subscriber management, forgetting about v6 for a second, just identifying our goals, right? If you're a service provider, there's a few things that you need to make sure happens when you bring on a subscriber, deactivate a subscriber, or something changes in that life cycle. The first is definitively being able to tell this particular customer, John Smith, has this particular IP address, right? Because a lot of our operational systems and enforcements are always going to be based on some sort of identifying metric, which for a customer, it's very easy for it to be the IP address when you're dealing with networks and IP networks, because we're going to then take that subscriber IP address and use it to control the speed packages, right? We're going to use it to track the bandwidth. We're going to use it to maybe add them to an address list in a firewall when they don't pay their bill, reactivate them. So like that IP address becomes very important. Now, these days, a lot of you are going to be using one of these vendors that I have on the right, Preseam, Sandvine, a lot site. There's a bunch of them out there. They actually take care of a lot of this, right? They take care of enforcing the speed packages once they know who the IP is. They take care of, tracking the bandwidth. They take care of shutting them down, turning them back on, and they'll integrate with your other systems like your billing system. So there's kind of a pendulum that, when you're starting out, all of these things are probably going to happen on a MikroTik. And then as you grow, you'll start peeling some of these functions off onto some of these purpose-built vendors like I have on the right. And then in a few slides down the road, I'll show you how it kind of all comes back into a BNG type format as well. But if all of these things are taken care of, realistically, we just need to make sure that a certain subscriber has a certain IP address, right? So in the IPv4 world, it's fairly simple. In the IPv6 world, it gets a little bit difficult. So in IPv4, you have your OSS BSS system on top left. It's going to send some data that'll include the customer information, and you'll most likely have the MAC address because you've gone and installed equipment at this customer's home. You're going to know what MAC address is there, and that's been the identifier for a couple decades now. And then your billing system, whether it's Splings, PowerCode, VISP, whoever it is, it's going to have some sort of IPAM built into it for you to be able to say, this customer has this MAC address, gets this IP address. And that's generally, there's a few different deployment options here. I'm not going to get into all of them, but one of the more common ones is that it goes into a DHCP server, and then we create a static reservation. So now when the subscriber CPE with that MAC address, on v4, this is all v4 at the moment, asks for an IP address, that static reservation was predetermined, right? So you can pretty much guarantee that this MAC address has this IP address and guarantee that it's this particular customer. And that allows all the other integrations to kind of flow through easily. Where v6 breaks down, however, is that MAC address doesn't always exist in the payload of the subscriber CPE trying to provision itself on the network. And several slides ago, Kevin went through different provisioning methods. With Slack, it doesn't really exist because those are really determined kind of on the fly. And then you kind of read router advertisements that are going over multicast every 5 seconds, 10 seconds, 30 seconds, and all that kind of stuff just happens on the fly. So you don't really have a good way of telling a host, I want you to be this IPv6 prefix. It doesn't really exist because there's no identifier. In IPv6 world, you end up with a DUID oftentimes. And there's really no good universal adopted reliable way, especially in the WISP world. The large cable and telco providers, they can generally control the devices in the home, the cable modems. They have a lot of say in that firmware. They can push it out to fit their exact use cases. But in the WISP world, and even the FIS world in some cases, you end up with a situation where you have no real idea how it's going to generate that DUID or IAD, interface identifier. Even the RFC, there's 4 different ways to do that. You can do it based on time, which is an RFC, which I don't think it's used that much anymore. I think it's very old. I really don't think it's adopted, but it's still there. It's still an active way of doing this where you have no way of knowing what it is until the first request goes out. And then whatever the timestamp that first request goes out gets encoded into the DUID. There are vendor assigned, DUIDs, kind of like where you assign, register MAC addresses. You can derive them from the link layer. You can't derive it from the UID, which is a little bit easier. There is another RFC 6939, which does derive the DUID from a MAC address in a predictable way, but I'm not entirely sure what the adoption of that is across all the different vendors that we see in our world. I'm just going to check the chat real quick to make sure no one's telling me my audio is bad or anything. Okay, cool. And for some of the naysayers out there, yes, if you go read RFC 4472, it is one of many actual RFCs published that go through all of the complaints and gripes and operational problems that IPv6 bring. And this is just one of them. So it's an interesting read. So then the question becomes, how do we deal with IPv6? Well, traditionally, PPPoE is an option. It does work, right? Because you can have PPPoE be backed by radius and deliver the IPv6 delegated prefix in the radius attributes. I'm not going to get into the pros and cons of PPP, but it's certainly not as favored in the broader community for it to be the solution, right? And I'm sure you guys are debating all this in the chat right now as I'm talking. So PPPoE isn't really what we want to do. If you do DHCP-v6 with radius, however, something interesting happens. So you can take a DHCP-v6 server, which is a stateful method of provisioning DHCP. And if you configure that with a radius backend, it's going to get the MAC address off the Ethernet frame and send it as the username on the radius access packet. So now you've got this identifier going through the network, even though it's DHCP-v6. So it doesn't really happen in actual DHCP-v6 if you're not using radius, because if this DHCP-v6 server just does everything locally, it's only going to look at the payload, right? And if you remember from a couple slides back, the payload doesn't have anything that's reliably identifying. It's just a DUID. But when we back that DHCP-v6 and tell it to go get its assignments from radius, all of a sudden it uses the MAC address on the Ethernet frame that request came from and is able to send that as a username, and we can use that as an identifier. So you can see on the right here, and this is watered down for readability's sake in this presentation, but this is a very, this is what you're going to see on the radius. It's going to send the username as the MAC address, and you're going to get back that framed IP address and delegated IPv6 prefix. And now we can tell the subscriber, hey, you are making a DHCP request, and I just asked radius what to give you based on the MAC address. And now I can respond and say, you should be this particular prefix. And that does work. So the answer realistically comes down to it's radius. It's whatever, 25, 30 years old protocol. But it really just comes down to radius. And I know a lot of people are like, yeah, why do I want to add radius? It feels like going backwards. It's really not. It's clean. Once you get it set up and you get some automation going, at the end of the day, it will still just be DHCP if that's your typical workflow, right? but it gives you the idea of deterministically provisioning IPv6. The other thing Radius does is it breaks you away from native integrations of whatever software you're using, right? Whether it's innovative systems, Mac, PowerCode, this, whatever it is, you know, a lot of times you kind of get into these billing systems and you have the native integrations to play with. When you start thinking about things in terms of Radius, all of a sudden your world opens up a little bit, because now it's a matter of just organizing data, and you can start using whatever vendors you want. I'll have a slide on that in just a second here. But what ends up happening here is, if you're, you know, in this case, we have the billing system giving the IPv6 prefix to the Radius server. If that doesn't happen in your billing system, whether, you know, if you're using something that doesn't support IPv6 natively, it's not a problem, because this is where we can use Netbox and its automation features to supplement your billing system with just IPv6 information. So what it will do is it'll allow you to keep your existing workflow with that billing system. You don't really have to change anything you're doing. And in the background, we can do a little bit of automation with Netbox and have an IPv6 prefix assigned, recorded to a customer. So what that looks like is something like this. So if you have a custom middleware that knows the billing system understands the MAC address, the customer, and IPv4 address, and then you have Netbox, which can, as needed, carve out and assign a v6 prefix, the middleware can act as a aggregator of that data, combine the data from those two sources, and tell Radius, hey, I got this username and IPv4 address from the billing system, and then the v6 address tied to that customer from Netbox is this. And now Radius will work with all of the information that's there, right? So that's the way to kind of do it. It's a little bit custom work. You are adding a couple systems into your workflow here, but once it's up and running, it's clean. We're using standard space pieces, and it's all automated. So I kind of built a proof of concept. There's a lot of billing systems out there. I don't know exactly what the distribution is of who uses what in our audience. Many of you know I've got experience with PowerCode, and I kind of worked with them on a little proof of concept here. They gave me just what I needed to make this happen. But you know, the basic steps would be to create the tower prefix in Netbox, and I'll have a screenshot of that next. And you set a role and say, this is a subscriber prefix. And then you can map the PowerCode defined v4 ranges to the Netbox defined IPv6 ranges, and it will automatically start creating the customer records from within there. So what that looks like is, here's what a middleware would look like, right? And this is actually real, this works. If you guys want to contact me, you can deploy this literally today. Is, let's say you have a tower called Jackson, and you've got a customer DHCP public and some other private DHCP on the PowerCode side, right? On the left-hand side, you can then map that to something in Netbox, to the /44 that we have at that tower at Netbox. And you'll see that I have a many-to-one relationship here, because oftentimes legacy, if you've been around for 15 or so years, you may have chunked your IP space in smaller ways, where you may have given out a smaller /28 to a tower, and then years later come back and give it another /28. And you've got multiple v4 address ranges living at a tower. But in the v6 world, all of those people should end up on the same v6 prefix. So we can have a many-to-one mapping here, right? So what this now does, if we kind of go back to, well, this is what it looks like in Netbox, and you can see that I just have a role on the left here for the /44 subscriber prefix. And then as customers come in, we automatically assign and create a /56, record which customer it is, and give it a role of subscriber delegated prefix. And it's not in the screenshot here, but you can record other metadata as well, right? Like other IDs in your billing system, you can have that attached to the subscriber prefix here, delegated prefix here. So once you have all the information, if we go back to kind of our workflow, this is what it looks like. We have our custom middleware that pulls information from PowerCode and Netbox. It aggregates that, sends it to a Radius server, and now the Radius server has everything it needs. We combine all of that with the workflow that we had with DHCP v6, and all of a sudden IPv6 provisioning just becomes possible, right? So we've deterministically assigned a IPv6 prefix just by aggregating those two sources and feeding it through radius. And going back to what I was saying earlier, is it kind of breaks you away from native integrations as well, because you can add other metadata into that radius server, and you don't need your netbox or your homegrown billing system or your off the shelf. You don't need any of that to talk to BNGs. So as you scale and as you grow, you may, and even this IPv6 conversation, CGNAT's a big thing. You may end up on a vendor like NetElastic, Casa, Nokia. All these vendors have like BNG like functionalities. I threw MikroTik in there. It's not really a BNG, but it checks all the boxes depending on how you configure it. But you can now make all of these things work based on radius, because they don't really need to integrate directly with any of your billing systems or other systems at all. As long as we aggregate the data into radius through a custom middleware of some kind, all these things start becoming possible. So I think that might be my last slide. I apologize for running through that, but I know we're over on time here. But happy to talk about this more, kind of in a Q&A style as we go. But this is a way to get over the hurdle of how do I get IPv6 to a customer, deterministically know that this customer has this particular /56, and then be able to tell pre-seed, be able to tell SISA, be able to tell my firewall, like, this is who this customer is, and report against that as well. So I do kind of want to have a soft ending here. I do appreciate everybody for joining. Awesome turnout. Really appreciate the feedback. Definitely get in touch with us if you want to talk to us some more. If you have any projects, we can do those as well. But happy to brainstorm and just chat and shoot the shit. Contact us via email, phone. Some of you have our contact information. Feel free to reach out. I'm gonna maybe leave the slide here. And I'll be in the chat for maybe 15-20 minutes longer, and we can, discuss any outstanding questions.
Hey, Sajin, I don't know that we have an actual question in the Q&A, but there's one thing that's been kind of going on in the chat as you've been presenting, which is the idea that we use PowerCode as our example, because obviously, you came from PowerCode, you know that network very well, but something that you and I spent a lot of time talking about was that this works for anything that does radius. Like, our whole point in being a consulting firm that is, tries to be a bit neutral in platforms and software is, that this could go into any system that you want to integrate, whether it's something that you've built, something else that you're using. And that was kind of the whole driving process of doing this, is that it was open and universal, within reason, if it supports radius.
Yeah, absolutely. And that's kind of the point here, right? Is once you start shifting your mindset between, like, I need these systems to integrate and support things natively in this particular way. Once you move away from that mindset and start thinking about things in terms of the data I need is in these 3 different places, and that's okay, right? As long as I can aggregate them into radius, everything becomes possible.
Got it. Yeah, no, I think that covers it. I don't know if you guys have any more. If you guys have any more questions, throw them in the chat or in the Q&A. But I don't think we have anything open right now.
Yeah, just to confirm, Drew, thanks for chiming in there. Yeah, barring any technical issues that happen during this, we will cut and edit the recording just slightly and send out the slides and videos to everybody. And I appreciate everybody that hung with us. I know we went a little bit over time. It's just such a big topic. We may even do a part 2 and dive deeper into specifics, like for 464XLAT, because that's an interesting topic as well.
Yeah, I think MPLS and routing protocols, I saw a lot of chatter around that. So I think possible, getting into 464XLAT and maybe a possible second webinar would be getting into how do you deal with this in routing protocols and overlays, and what does that look like in different types of networks. So maybe there's material there for a second webinar on that.
Yeah, absolutely.
Well, cool. I think we're going to get off audio, and then, like Sajin said, we'll monitor the chat for a little while. But thanks everybody for joining. We had an awesome turnout, way higher than I think we even anticipated, and so this was great. We really appreciate your time.
Yeah, I will answer Ray Taylor. Nice to see you in here. I know you probably missed a little bit of it. So the goal is to kind of move away from what your traditional integrations are. So it's not so much telling your existing, OSS BSS system specifically how to use radius. It's go grab the data you need from whatever sources has the data. And it's very easy to build the radius attributes. And then you just tell your actual routers in your network, whether they're Junipers, MikroTiks, whatever supports DHCPv6 with a radius backend, you just tell those directly with configuration, hard configuration, to go check this radius server.
So Sajin, if you check the Q&A, I think there's at least three questions or
Sure.
2 questions in there.
Can you confirm that MikroTik DHCP v6 server will send the Ethernet MAC address? Yes, Jesse, I can confirm that. So DHCP v6, when you hit the use radius, I can confirm that because that was my actual lab. I did have a live demo built for this presentation showing off exactly that, but I dare not do a live demo anymore remotely when I'm on Bluetooth, wireless, and remote. So, but yes, that is the exact behavior, and that's also the exact behavior of a lot of the systems that I have on the screen here as well: NetElastic, Casa, Nokia BNG, Juniper BNG. That is how radius-backed DHCP6 works. And I do want to give a quick shout out to the NetElastic guys. NetElastic and PowerCode, both PowerCode definitely gave me some access to make the lab and everything happen to validate some of this. And the NetElastic guys were kind enough to give me some insight into how their system works, kind of validate some of this as well. Nick Eastman, is there some reference for setting up radius and DSP relationship? That's going to depend on the vendor, right? In the MikroTik world, it's legitimately a checkbox, right? You add the radius server and say, use this, make this radius server available for DHCP. And then when you're configuring the DHCP v6 server, it's very honestly just a checkbox to tell it to use radius. And you do that in conjunction with not setting a pool. You make sure that the local router is not looking to assign out of a local pool. So radius is the only place to get its lease information from. So, and Nokia BNG does the same thing. Juniper BNG does the same thing. Casa, NetElastic, they all have similar things. But exactly how to do it, it's going to be very vendor specific.
Cool. I think that's it. I don't see anything else in the chat or anything else on the open questions. So like Sajin said, we'll monitor the chat and answer for a few more minutes and go ahead and get off audio. And thanks again, everybody.
Yeah. Thank you, Nigel. I mean, I think I was looking at the attendee list, and I think we, aside from Antarctica, I think even in this webinar alone, I think we had people from legitimately every corner of the planet. So I appreciate everyone joining and hanging out with us today. I think we got
almost every time zone in here.
Yeah, and I'll probably send the recording out on Friday. And if not, it'll be Monday at the latest. And if you don't get it and you're still here listening, just reach out to us. We'll happily send it out pretty quickly here. So there's a question about best monitoring systems for IPv6 deployments. That's an interesting question. I don't think the monitoring system is the side that you have to worry about so much, right? If they're using typical protocols like SNMP or they've got agents, like those are all going to ride IPv4 the same as IPv6. I think what you really have to worry about is the actual end devices that you are monitoring. If, for example, they may require an IPv4 address because they only listen on IPv4 for SNMP queries, for example. And I don't know that anybody's done the work to validate. I certainly haven't. That might be something that we do, Kevin. But like, if I've got a Ubiquiti radio out there that I'm using SNMP for, and it's got a v6 management address, which I don't even know if that's possible yet on certain product lines, but I don't know that I can hit SNMP on the v6 management address on every product.
Yeah, I'll actually speak to that. When you're running a pure IPv6 network, so there's a lot of people we talk to that work in the research and education space that build some pretty big networks for supercomputers and things like that. And running v6 only networks is something they do a lot of. And there's, in a lot of cases, when you're running an IPv6 only network, meaning that everything except for possibly, IPv4 on top as a service to the customer or subscriber, is everything under that is all IPv6, including your management plane and all of that. That is certainly possible when you have the right combination of things, but you'll find that there always tends to be a very small percentage of things that break. And when you get into the weeds of things like SNMP and NTP and these other management protocols on different vendors that, your router vendors and switch vendors, they've made most of that stuff v6 capable for a while. So routers and switches tend to be pretty good, but when you start getting into things like radios and CPEs and just custom boxes that you're going to be putting out, like I'll give you a really great example. Power and environmental monitoring, like trying to get IPv6 on that stuff is like pulling teeth. Some vendors have it, but like you may have to keep v4 around in your world just to do power monitoring for a UPS or a rectifier, whatever your power plant looks like. But anyway, it's one of those things that most operators have a ways to go to get to a pure v6 only network. That said, there are a lot of benefits to operating a v6 only network. Your address planning and operation gets so much easier. Being able to build ACLs against a lot smaller range of prefixes is a lot easier when you're doing a v6 only network. So once we get over the hurdle of support in things, there's some huge benefits to running a v6 only network.
And that's where like you start thinking about we still got quite a few people in here probably listening or not, who knows, we might be talking to the air, but that's where you start thinking about like the phased, like the long-term phases, right, Kevin? We've got a v4 only network today. We add maybe some dual stack just for subscriber delivery, then we can kind of v6 our own infrastructure and core and middle mile pieces. But at some point you kind of hit that road and like you're v6 enough where you start peeling away your IPv4 and only do that 464 XLAT for specifically the host that need it, rather than running a fully dual stack network. Is that a fair long-term outlook?
Yeah, I mean, if your gear supports it, then starting the move towards it is the way to go. And I think there's an important point to put out, because I put out a lot of content about IPv6. I'm pretty passionate and outspoken about using IPv6, and as are a lot of other people. But we have to be realists too, in that it's a journey to get there. You're going to have mixed v4 and v6 for a while, because everybody's on that journey. Even some of the best well-run networks that have done v4 only have still had some weird quirks that they may have 1% of the stuff that doesn't support v4, like a console server or something like that. So it's one of those things that realize you don't have to boil the ocean in a day. It is a journey. You can enable small parts of the network on IPv6 and just keep adding to it. And before you know it, you'll have a great dual stack network. And then, as you progress forward, you can start dropping out some of the IPv4 stuff as, not only as the world tips more towards IPv6, but as vendors, improve support for it. So slowly you'll be able to get down that road if you start now. And the most important thing is just start playing with it, get comfortable with it, get it out there, understand what in your world is a challenge. Like if you run Ubiquity can only address a /64. You can't, at least in the last time I tried, which is probably a few months ago, on the whatever the latest code of Ubiquity's routers are, you can't assign a prefix anything other than a 64, which if you're trying to do loopbacks or something some kind of special addressing could be problematic. So definitely one of the most, in the WISP space, Ubiquity is probably the most limiting IPv6 component from a routing perspective. The radio gear is just L2, so it doesn't matter as much unless it's on the management side. But anyway, as you work through those issues, you will get further forward and get to a point where you're deployable. We have a lot of customers ranging from very, very small startups all the way to very, very large regional ISPs that all have gone through this journey and started to put IPv6 into prod. So it is possible. You can get there. You just have to, the old adage, you eat the elephant one bite at a time.
Kevin, there's another thing to maybe just comment on. A lot of people are turned off by IPv6 because, operationally certain things just weren't practical 10 years ago, right? A lot of RFCs have come up, including, the 6349 RFC, where it derives a DUID from the MAC address, right? Like that's something that really makes a lot more sense. And there's others that are even more recent than that in the past 5 years to help adopt and help kind of clean some of these edges off. And yes, we can say it's not finished, but would you say that like we are moving towards a direction where some of these gaps are being filled, or is the dogma of like 10 years ago and IPv6, staunch mentality, is that maybe still prevalent?
No, there's a lot of gaps getting filled. I mean, you look at the uptake rate with IPv6 adoption. the rate at which the global table is growing. I think, when I first started, the global table for IPv6, when I first started getting into carrier networking, was like, it wasn't very much. It was like 10,000 prefixes or something like that, which was a long time ago. And now we're at 140,000 or 144,000 prefixes, I think I last saw in the global table. And so that sprawl of all these services means that, that trickles all the way down to the people that are, developing in the Linux kernel, the application developers, the network vendors. Some of you may have seen Networking Field Day, which is a group that I'm involved with. We go talk to a lot of the Silicon Valley vendors like Cisco and Juniper and a whole bunch of others. And we talk to their developers and the things that they're making and that they're building. And we always ask about IPv6. And in especially in the last year, they have answers now. These vendors have answers for IPv6 questions, whereas when we would ask those questions 3 or 4 years ago, there weren't really, and it was just, oh, it's on a roadmap, and it became almost a joke that IPv6 is perpetually on the roadmap on this road that you never quite get there. But now people are recognizing that IPv6 is not only in service provider but enterprises. There are some really, really big names in the Fortune 500 that are starting to use it, partly because of scale, partly because of the cost of IPv4 addressing. But my personal opinion is that the tipping point that people have been talking about for years, we're finally there. V4 is expensive. V6 is here. You can deploy it and run prod on it, and it's time to tip the scales and get into V6. And we'll probably have another few years of transition before we see mostly V6 as far as compared to V4, but we're definitely in that hot transition space that everybody is adding it and getting into V6 now.
One other note, there was a question just now about what kind of prefix link to assign to a customer, residence, or business. And we recommend /56, but like there's really problems that you can develop if you actually assign something smaller than a /64 or a longer prefix than a /64, because I've noticed a lot of consumer devices, in some weird way, I don't know the details under the hood, but in some weird way, it's almost like if they're not on a /64 subnet, they do not work. Like they're expecting that hard coded.
No, that's totally right. You do not, unless you're running a data center or an enterprise where you're going to be assigning an address because you control the L3 gateway and you have a host joining like a Wi-Fi network or a server network. In most cases, you're not going to want to ever assign an address to a customer the way you do in the V4 world. You want to assign a prefix. And there's no really good reason to assign a very small prefix. If you go look at RIPE and you look at ARIN, they both recognize the two prefix ranges that are the most common, that are both considered best common practice, are a minimum of a /56 and a /48 is the standard. And it just depends on what kind of operator you are as to what you want to assign and what you want to delegate. But that's it. It's always going to be a block going to a customer, and then their router will pull a single 64 out of it and put it into prod on that LAN segment. But you definitely don't want to do that and assign an address in the provider world. You'll have a lot of problems. And to your point, Sajin, assigning anything beyond a 64 is just asking for pain. That is just asking to punish yourself. It probably seems like, I know it seems really wasteful. If you're new to IPv6, having these billions of addresses get wasted on a single home seems like, oh my God, we're wasting all these addresses. But when you realize how vast the IPv6 space is and how much of it that we have and how much is, and even just how much is in reserve, we're only using, even though of the assigned pools to the RARs, we haven't used a tiny fraction of that. The assignments out of the total IPv6 space to the RARs is only a tiny fraction. So, obviously, I'm sure we'll run out of it at some point. I don't know, 70, 80 years, 100 years. But for the next 20, 30, 40 years, it is incredibly unlikely that we're going to see, any threat of running out of IPv6 space. We're going to have it for a long time. And I'll tell you, I'll explain my favorite math to give you an idea of how vast the IPv6 space is. And this is a guy by the name of Jeff Carroll. He's a famous author in the Cisco press space. He had a course that I took years ago that described if you took a 64 and you burned 10 million addresses per minute, it will still take you 57,000 years to exhaust that 64, burning 10 million addresses per minute. That's how big IPv6 is. And it's really hard to envision it. But when you think about that's how big just a 64 is, think of how big the aggregates that hold that 64 are. So a good question came up from about greenfield internet, about foregoing IPv4 totally. You definitely don't want to do that. If you're in a region where IPv4 is really, really hard to get, I would probably recommend that you look at maybe a single stack deployment where you run IPv4 as a service and use the CGNet gateway. So you get a very, very small amount of IPv4, enough to have a good pool for CGNet, and then run IPv6 as well as IPv4. But if you forego IPv4 entirely, there's still going to be sections of the internet that just don't work. And that's getting better, but we're definitely not quite there yet. So, things that will still generally work on IPv6 only, the YouTubes, the Netflix, Disney Plus, most of that stuff works on IPv6 only. Where you get in the weeds on things like this are as these big companies have moved to transition to IPv6, if they weren't IPv6 native, you'll often find that the web servers are on IPv6 and they're listening on IPv6, but they may have an IPv4 backend. So like login and authentication processes are a very common trap for something that's front ended with IPv6, but it's IPv4 on the backside. So if you hit a web server that makes a call to another public DNS name that's v4 only, and you turn v4 off, you're probably going to have a really bad day. So make sure that you are in some way providing, access to the v4 and v6 internet, because doing it IPv6 only, there are a few orgs that have gotten away with assigning just an IPv6 address to a home, and being able to convert that through, NAT64 at the gateway. But the other problem you have when you're a carrier is there's so many devices in the home that still don't do IPv6. Like Roku is a great example. Unless they've added in like the last 30 days or so, they're still IPv4 only. So if you're a carrier in the US or Europe or anywhere that uses a Roku, if you don't assign IPv4 addressing, even, RFC 1918 private to things in the home, you're going to have a lot of angry customers. So definitely get in the mindset that IPv4 can live at the endpoints and it can transport over native IPv6, but you still need that v4.
And from a greenfield perspective, we're rapidly approaching that tipping point where because it used to be that we could just do CG, quote unquote CGNAT or some sort of NAT on a MikroTik router and hand out those private v4 addresses to subscribers. But even the price of IPv4 is rapidly getting to a point where you may as well just buy yourself a purpose-built CGNAT type appliance from A10 NetElastic or an actual Juniper, something that is purpose-built for natting, because the pricing actually makes sense given where v4 is.
Yeah, it's definitely something to go take a look at. And the other thing I would encourage you, if you are trying to transition to IPv6, and this is Aaron specific, but I believe the other RARs have pools for this, is that if you're in Aaron's region, there is a section of their rules, it's 4.10, I believe, that they will give you up to, I think, a /22, which you have to justify, obviously, of IPv4 space if you're planning on migrating to IPv6. So if you need IPv4 for things like CGNAT pools, or other transition technologies, so that you're not using current IPv4 space, to do natting and do IPv6 transition, they will give you v4 space that's not really a waiting list that you can get on and use that to help in your v6 transition. And so that's, if you're not familiar with it, go look at 4.10, fill out the justification, and get some more IPv4 space from Aaron to help you with that IPv6 migration, because it's out there. And they, as long as you're going to use it for IPv6 migration, Aaron is more than happy to give it to you.
And I mentioned this in the chat. I don't know if this was confirmed or if it's a rumor. I don't know this to be true, just being very clear. But right now, if you go get a /32 from Aaron of v6, are they reserving or at least keeping empty the contiguous blocks so that if you go back and need more v6 space, they can just change your /32 to a 28, without you getting a separate 32?
As far as Aaron, the last number that I heard is I think they reserve a /29 of IPv6. That is not V4.
Mhm.
They reserve a 29, which gives you several contiguous 32s that are, numbered in sequence with yours. And that everybody that when you request a 32, they reserve a 29. I think if you get a bigger block, they reserve a bigger space. So somebody just said Ripe does, somebody got a 29 from Ripe. So I know Ripe
Nice.
does a reservation as well. So that, depending on where you are and which RAR you're in, it'll depend. But yeah, you can go back and that's the great thing about V6 is you can keep going back to the well as long as you can justify the sites that you're using, which is really where the RARs want to see is, they don't care about the number of addresses or, really even the number of subnets. Technically it's just how many sites are you going to have? And, a site is a very, fluid definition. And so normally that's the justification of how many sites you're going to have, or if you're a cloud operator or doing some like lab work, a virtual site, as it were, is still valid, if you write the right justification for it to get a bigger, IPv6 block. So yeah, definitely that's where it's all aligned around. And they do make those reservations.
And those, when you're responding to those tickets and providing a justification in the V6 world, it is more, from my experience at least, it is more based around your subnet planning, whereas in V4 it was more around justifying the usage. So
Correct.
that's something to kind of keep in mind as
Yeah,
you
in the
fill those
V4
out.
world, because it was a scarce resource, every single address had to be accounted for. In the V6 world, they can't give away IPv6 fast enough because the RARs want to help people get it into operation. The only thing that they do so that they have some kind of a system to justify it is how many sites do you have, and if you have this many sites, you might even get something like a /40 or /38 or different lengths from the RAR, but the most common one is a /32. Even small startup WISPs will normally get a 32 if they say, hey, I think I'm going to have this many sites. They're going to be in operation by this time frame. Then they'll generally give out a 32. So at least in the US and Canada and Mexico and the Caribbean, 32 is the most common that I see.
So just to give everybody an idea, we had a lot of people in here during the meeting. We are now 45 minutes past the end time, and there's about 75 people still hanging out with us. So if you've got questions or if you're just listening, feel free to throw them out there. As that number dwindles, we may even, I don't know what your schedule is like, Kevin, but we can maybe even turn this into a town hall or maybe schedule that a little bit later.
Yeah, I think I'm good for maybe another 15 minutes, and then we'll probably call it since we're definitely way over, but totally happy to keep, as long as the questions keep coming, we're happy to hang out. There's one question about a bug in MikroTik. I'm not familiar with that specific bug. You'd have to post the version of RouterOS that you're using, because I don't know that I've seen that one specifically and what version that's in and what the conditions around the bug are.
For anybody interested, I may post this out on Stub Area or tweet it out or something. I did write, and please bring in a more technical question or topic in the chat, but I did go through a word list, several word lists in the English dictionary, and I parsed through any 4 or 8 letter words that were able to be spelled either using A through F or leet speak, where the 4 is an A, the 7 is a T. So I do have a giant list of words that you can spell inside of IPv6 that I'll probably publish if you guys want to include some cool stuff. I think in our earlier slides we had, what was it, cool cola or something like that.
Yeah, I did cold cola, I think was one of them.
Yeah.
Taco Cafe, using a 7 as a T, is another favorite of mine. The Taco Cafe is a big one. That's a shout out to Faisal down in Miami. If he's on here, he's the taco man. So there's a couple things here in the questions, Sajid, we could probably go through.
Sure.
One, MikroTik, Manish says, I'm using MikroTik for integrating with a Radius server. I'm using Sonar. I believe Sonar would Sonar be a similar configuration to Radius?
Yeah. Now I'm
or
unclear.
Splinks or any of those others. I think we already talked about that a little bit, but just to reiterate
Yeah.
that for the open questions.
Yeah, it's all the same. Like once you start thinking in terms of radius, it's all standards based, right? So it really just comes down to where the data is. So if you're recording v6 prefixes in Sonar in Splinks, and there's a way to extract them, maybe even natively into free radius. This what you see on the screen right now is possible with almost any data source. And if it supports v6 natively, if the OSS BSS supports it natively, that's great. If it doesn't, that's when we, if I go back to a few slides, that's when we add just netbox just to supplement that v6 piece in a very strategic, narrow way, just so you have the whole piece. So if you're
Right.
using Sonar, Splinks, whatever it is, you can, and even in-house systems we've done this with, right?
Yep. There's another one about DHCP v6 PD on Ubiquity. I've had a lot of problems on Ubiquity. Ubiquity is it probably, being that we're known for being, the biggest microtech consulting firm in the world, people probably think we hate Ubiquity. We actually don't, because we are independent. We work with everything, but Ubiquity at layer 3 has a lot of challenges with IPv6. They never really finished the implementation, so it works in a very basic level. I've gotten DHCP v6 PD working on Ubiquity. I think we were doing it on an Ubiquity GPON network. But it was not easy, and it did not it's not as robust as MikroTik's. Now, to be fair, MikroTik has some holes in its DHCP v6 PD implementation, but it's way further ahead than Ubiquity's. And I think that dovetails well into a comment that somebody made about where was it? They were asking about RouterOS version 6 for MikroTik as it relates to RouterOS version 7. And there are some gaps. I've got a blog article if you go to stubberry51.net, where my blog is. There are some gaps in RouterOS version 6, like recursive addressing. You can't do recursive routing, except I think one hop away it works, but anything beyond a single hop, it doesn't work for recursive routing. So if you're trying to do loopbacks or IPGP or anything that needs routing recursion with an IGP, it doesn't work in RouterOS version 6. Obviously, if you're using something like FiberStore, Cisco, Juniper, Nokia, those all work, just fine and have for a long time. This has been a specific limitation of MikroTik because they've been on that old Linux kernel in version 6 for so long. Now that version 7 is out, and it's on the newer Linux kernel, that's all fixed. In fact, there's a blog entry. I need to update it for the latest version of RouterOS version 7. But when RouterOS version 7 first came out in beta, we tested things like ECMP and IBGP with routing recursion, and that all works, and it still works. So that's all definitely there and working and fixed. But RouterOS version 7, as I think we talked about in the chat, it's probably going to be June, July, I think, before it's really ready for prime time. We use it in very simple use cases when we're not using a ton of dynamic routing or doing a ton of things in the config. It generally works and is stable. When you start stacking a bunch of features up like MPLS and BGP and OSPF and shaping, there's still some work there to do, I think, stabilizing it as well as filling in features. So my target, if you're an operator trying to move to 7, would be test it out in simple use cases, but probably wait until summer if you need to get into more complex protocols to plan to go prod. So that's my overall statement on version 7. Let me see if there's anything else in here.
There's a question, like, yes, I have put MikroTik on here with the Junipers and Nokias and Elastic, and no, they're not comparable, right? Like it's on this list because it checks the box of the function, but there is a point at which MikroTik hardware is going to fall over, right? Where if you've got 30, 40,000 plus subscribers, even in if you're the 100,000 million plus subscribers, there's really no real good reason to use MikroTik. If you're aggregating that many subscribers, it's not going to serve those purposes, but it does fulfill those functions, the same functions in a smaller network. It's really just on here just because we have a lot of people that are at the smaller end of scale, and we have some people that I know even in this webinar we had some people that were well over 100, 200,000 subscribers.
Yeah, and I think it's important to note that we like Sachin said, we do cover a wide range of systems, so it depends on the operator. There are several national level networks we worked on where we've built like country level networks for some countries in Africa and Latin America where we've built like their national backbone. And MikroTik is often very, very common there. Although, the bigger networks will often use Juniper or Whitebox like IP Infusion in the backbones and push MikroTik out towards the edge just from a capacity standpoint. when you need things like, multiple 100 gig links and things like that. But it does work as a BNG, like Sajid said, in a very basic way. And if you want to get into more advanced protocols, or the protocol that you need specifically in the BNG, isn't supported, like if you want to do IP unnumbered or, something like that, then you would get into Juniper and Cisco, Nokia, or Whitebox with IP Infusion, or NetElastic, which is a virtual BNG that we've been working with a lot. So yeah, we use MikroTik a lot just because we work with a lot of wireless ISPs and startup ISPs that like to use MikroTik. So we tend to use it in our examples, but it will work on, this will work on anything in the spectrum of gear that's out there for carriers.
Sorry, I'm replying to Ray Taylor in the chat here.
Oh, here's a good question. Carlin Ray's got a great question. He says, what I'm hearing is that if we are less than 2,000 subs, we can implement IPv6 on RouterOS version 6 just fine and don't need to wait on v7. Absolutely correct. You can do prefix delegation and use OSPF v3 as long as you're not doing loopbacks, and deploy IPv6 on MikroTik. And that's worked for years. There have been ISPs that have been v6 dual stack for years on MikroTik RouterOS version 6. As long as you know where the gaps are and what the roadmap is towards v7, you can deploy on v6 today. You just need to be aware, if you're running an IBGP ASN, the way we do it most often for clients is that if you're running IBGP on v4 and you're using BGP and OSPF, you're still going to need OSPF when you do IBGP on v6. But to get around that gap, unless you just want to go out and spend an enormous amount of money on, another vendor and wait for MikroTik to get that functionality enabled, then we do OSPF v3 only on the v6 side until v7 is ready for prime time, and then we come back and add IBGP so that the v4 side looks just like the v6 side. And then another interesting note, MikroTik did add support for IPv6 next hops for IPv4, as well as LDPv6 for MPLS. So at least within the scope of MikroTik, the day is coming when you will be able to run a v6 native backbone and run IPv4 on top of it as a service, whether that's using BGP with v6 next hops inside the AFIs for BGP, or you want to use LDPv6 and run MPLS as native IPv6 with a service on top of it, or you might use both. But in any case, it's deployable on v6. You can totally get it into prod. It works. And then there's some additional functionality and things that you can do in v7.
Cool. We're coming up on the hour here. We'll probably call it.
Yeah, I'm going to answer one more question because we've talked all about provider, but I see one question here that's more in the enterprise space. So I'm gonna take it, and then we can call it, Sajin. Kristaps asks about he's got a medium-sized company that are doing IoT development. They've got 3 different office locations, and his ISP's provided IPv6, which is probably going to be the provider assigned and aggregated IPv6. He said, can you summarize advantages to enable it for employees in offices, VPN compliance, and things like that? Here's what I would say. If you're running it as a company, one of the first reasons you need to enable IPv6 is that when we do security audits in IPv4 only enterprises, I think almost every time without fail, we find traffic that is getting tunneled over IPv6, that if you don't have IPv6 turned on, you have security risks that are in your network that you have no idea are happening because you've never turned IPv6 on. So it is a myth that just because you haven't turned IPv6 on doesn't mean that hosts can't use tunneling protocols and other mechanisms to deploy IPv6, maliciously and without your knowledge into the interior of your enterprise or medium business. So the very first reason to turn it on is so that you know what people are trying to do. Because if you're not running firewalls and security protocols in IPv6, you don't know. So that's my first reason to turn it on. Second reason to turn it on is it gets a lot better when you're using IPv6 natively for real-time protocols and endpoints, because you have a public address. You don't have to mess around with NAT. Sometimes you have to do port forwarding. Sometimes you have to do a bunch of different things to get that all working. In IPv6, it's end-to-end communication. And I'm going to go ahead and put out, there's a VPN service that we use that recently got integrated with MikroTik called Zero Tier, which is one of the most flexible VPN overlays that you can use, because it is equally comfortable with IPv4 and IPv6, and it can shift between them on the fly. So you can have IPv4 endpoints on one side, and you can have IPv6 endpoints, and they can all mix and they can change. Like I've changed from being on a V4 only network to 5 minutes later, I'm on a V6 network and everything still works. So not to say that IPsec or SSTP or any of those are bad, and they also can work on IPv6, but I've not found any as flexible as zero tier. And so when you have people that are distributed globally, being able to leverage IPv6 may be the difference between a good experience for a user over VPN and not. I actually saw, I think it was 2 days ago, there was some chatter on Twitter about an IPv6 path from the US to Australia was only like 210 milliseconds, and the IPv4 path was like 280. And so people were using I think Zoom and some other collab apps, and they were trying to use IPv6 because they were just getting a better response time. And not to say that every IPv6 path is going to be faster or have a better response time, but in general, you find that IPv6 does tend to have a slight performance edge over IPv4. If for no other reason, if you forget everything else we talked about, you just don't have the delay of going through the NAT and the state points and your end-to-end addressing. So we have some ISPs, especially in the telco space, that are starting to explore using IPv6 for like telco SIP and doing telco style voice on top of, because they don't have to worry about NAT anymore, and they can address SIP conversations end to end on IPv6. And same with video. It's great for real-time protocols. So going back to the original question about why using it in a company, the security, the flexibility, and the ability to leverage both protocols depending on where you're at is why I would use it inside of an enterprise. And the sooner you get it in your enterprise or small medium business, the sooner you'll be able to work with it and understand what you need to do to migrate over to it, so that you don't get several years from now and need IPv4 space and have no IPv6 strategy and no way to move forward. So I think it's very, very important that you get started, even if you don't feel that you have a strong driving force in your company, because those have a way of popping up overnight, and then it's a fire drill. And with that, there's probably 1,000 things we could go into for like hours and hours and hours, but I'm going to leave it at that. And then if you guys have ideas for topics, there's things you want to hear more about, hit us up on Twitter, LinkedIn, email us, whatever, and let us know what you want to hear about for IPv6. Because I think Sajid and I said that in the next 30 to 60 days, we'll put together another one of these and hit a different set of topics on IPv6 or other things in general.
Yeah, absolutely. Thanks everyone for joining, hanging out with us. We'll talk to you later.